Hi guys, in this video what we're going to do is going to look at surds, how to manipulate them, how to simplify them, and a few other bits and bobs. Okay, so the first thing to be aware of is what a square root is. So you can see here we have the square root of a, where a is greater than or equal to 0. It's the non-negative square root of a. So that's really important, the idea that it's the non-negative square root of a. So root 16 is equal to 4, it's not equal to plus or minus 4. Now, you can see here underneath we've been told that two important properties of square roots are square root of a times b is equal to the square root of a times the square root of b, so we can break it up. And also we have the square root of a over b inside the square root is equal to the square root of a divided by the square root of b, broken up a little bit like rule 1 here. There's a few other rules as we go along. So the first thing I'm going to talk about is that of simplifying surds. So I'll just do it through an example so you can see what I'm trying to do. So if we have a look at the square root of 8, what we're trying to do is we're trying to make this as simplified as possible. It's a bit like taking a fraction and writing it in its lowest form. And we're going to do exactly the same with the surd. Before we do that, it's important to note that we're looking for certain types of numbers when we're dealing with surds, and those are the perfect squares. And the perfect squares, I'm sure many of you know, are what you would consider to be the square numbers. So 1, 4, 9, 16, 25, 36, you get the idea, etc., etc. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc. The reason these are important is I know what the square roots of these are. I know the square root of 36 is equal to 6. The square root of 25 is equal to 5. So when I'm breaking up the surds and trying to simplify them, I'm looking for square numbers to go into or to be a factor of what's in the square root here. So hopefully you can see that I could break up root 8 and I can say this is the same as root 4 times root 2. And the reason I chose 4 is it's on my square list, or the perfect squares here, and I know that root 4 goes to 2. So I can change root 4 now to 2, and then it's multiplied by root 2. So root 8 can be rewritten in a simpler form as 2 root 2. Okay, let's do another one. What about root 50? Okay, so let's have a look. I'm going to try and break it up again into two values. So I want root something times by root something else. And I'm looking for one of these square numbers. So 4 doesn't go in, 9 doesn't go in, 16 doesn't go into 50. 25. So 25 times root 2. So that there, root 50 has been broken up to root 25 multiplied by root 2. And I know what root 25 is, because root 25 is just 5. And then we've got the root 2 on the other side. The reason we do this is, suppose I wanted to add root 8 plus root 50. By getting them into the same square root, that means that we can just add them together. So root 8 we know from above is equal to 2 root 2 plus, and this is going to be 5 root 2. And I have 2 lots of root 2 on the left here. I have 5 lots of root 2 on the right, which means when I add them together, I have 7 lots of root 2. We're going to do another example of that. It's example 1 here. Let's have a look at that now. So what we have is 3 by root 20, so 3 by root 20, okay, plus 2 by root 45. So we're trying to find some square numbers that will go into 20. So hopefully you'll see the 3 stays where it is. And for root 20, we can break it up as root 4 times root 5, because 4 times 5 here is 20. Remember, I've chosen 4 because I know the answer of root 4, I know it's 2. On the other side here, we have plus 2 lots of, and root 45. Again, we can break that up, and hopefully you'll see it's root 9 times root 5, because 9 times 5 is 45. The reason I've chosen 9 is I know the answer to the square root of 9. Let's work out the next line. So I now have 3 times 2 times root 5, because the square root of 4 is 2, plus 2 times 3 root 5 here. So 2 times root 9, which is 3, by root 5. Tidy it up again. 3 times 2 is 6. So I've got 6 root 5 on this side, plus another 6 root 5 on this side, which means I now have 12 root 5. And just have a quick look, you can see that we're supposed to have a k root 5, where my k is equal to 12. If we have a surd and another surd, like this one here, or if we have a number, just a real number and a surd, you can see you've got 2 minus 3 root 5, 5 root 2 minus 2 root 3. So just a number plus a surd, or a surd plus a surd, or minus a surd, then that's called a compound surd. The surd conjugate is where we change the sign of one of these. It's usually the second one we change. So here we've got 2 minus 3 root 5, so we change the minus 3 root 5 here to a plus. Here you can see we've got minus 2 root 3, we change to a plus 2 root 3, and here we've got a minus root x to a plus x. I'll do another example. Suppose we had 3 minus 5 root 6, then the conjugate would be 3. We change the sign, so we change from minus to a plus 5 root 6. Now the conjugate's really, really, really useful in getting rid of square roots from the bottom of a fraction. So you can see here we've been asked, without using a calculator, to express this expression here, 1 plus root 3 over 2 minus root 3 in the form k plus m root 3, where k and m are members of the natural number family. Okay, so what we do, so here's what we do. We do 1 plus root 3, okay, over 2 minus root 3. And what we do is we work out what the conjugate of the bottom is. So we're looking here, the conjugate of this, instead of 2 minus root 3, would be 2 plus root 3. So we're going to write 2 plus root 3, and what we're going to do is going to multiply the bottom by 2 plus root 3. Now we know it's a fraction, so whatever we do to the bottom, we have to do to the top. So we're going to multiply the top by 2 plus root 3, and we'll see what happens. Now, you may or may not have noticed that this is a difference of 2 squares, because the difference of 2 squares states that x squared minus y squared is equal to x minus y by x plus y. And what we have here is we have x minus y by x plus y, where my x is equal to 2 and my y is equal to root 3. What this means is we're going to be using it backwards in order to find out x squared minus y squared. We can do it fairly quickly if we use this method. The top one we just have to multiply out. So we're going to multiply the top out. If we do that, just however you want to do it, multiply that, and then that by that. Let's sort that out. So if I do that, I'm going to get 1 times 2, which is 2, plus 1 times root 3, which is root 3, plus root 3 times 2, which is 2 root 3, and root 3 by root 3. And if you have root 3 by root 3, you get root 3 times root 3. That's root 3 all squared. And you have a square root and a square next to each other. They all cancel out, and that ends up being 3. So that's equal to 3. Okay, then that's all over. And I said that what we have on the bottom is we have this idea of the difference of 2 squares. It will always be the difference of 2 squares. That's why we do it. That's why we change the sign, so we can actually make it the difference of 2 squares, which means we're going to use x squared minus y squared, where this is my x, this is my y. So what we now have is x squared, which is 2, so it's 2 squared. Okay, you can put it in a bracket, minus, and it's root 3 all squared. And now we're just going to tidy up. So first one, the top, very straightforward. You just multiply it out. We'll tidy it up in a second. The second one, if you look at the bottom, it's a difference of 2 squares, and we can use this just to quickly get it out. If we don't use this and we multiply it out, we're still going to end up with this minus 2 root 3 cancelling with this positive 2 root 3. So it doesn't matter if you multiply it out. If you forget it's a difference of 2 squares, you'll still get the answer of the 2 squared minus the root 3 squared anyway. Okay, so let's tidy it up. If we do that, we now have 2 plus 3, which is 5. And we have plus, and it's 3 root 3, is it? So 3 root 3, yeah. So 5 plus 3 root 3, all over. And 2 squared is 4. And root 3 squared is 3. Because root 3 by root 3, we've done it at the top there. So that's going to be minus, and it's going to be 3. tidy it up again. We're going to get 5 plus 3 root 3 all over 1. And of course, over 1 means we can get rid of it. So we've got 5 plus 3 root 3. And that there is of the form k plus m root 3, where my k is equal to 5 and my m is equal to 3.